When we think of dinosaurs, we picture apex predators towering over the landscape. But the reality of their origin story is completely different. Take one of the earliest known dinosaurs, Eoraptor. It roamed the Earth 231 million years ago, measuring only about a meter long and weighing less than 10 kilograms. An average adult dog today is heavier. Throughout most of the Triassic period, dinosaurs were a fringe group. They made up less than 10% of the large vertebrate population, completely eclipsed by massive, dominant crocodile ancestors that ruled the riverbanks and plains. Their eventual 160 million year reign over the planet didn't start because of a biological advantage. It happened because of the brutal, extreme geology of the landmass they lived on. Slide a map of modern continents backward in time 300 million years. They merge into a single colossal monolith, Pangaea. Because it was so vast, ocean cooling couldn't reach the interior, creating a massive arid zone in the center, indicated by deep red. It was an environment defined by extremes. Summer temperatures routinely exceeded 40 degrees Celsius. The immense landmass heated rapidly, causing air to rise violently, dragging moisture inland and triggering constant, chaotic climatic instability. We can still see the scars of that harsh climate today. Geologists call these red beds. These towering rock formations are vast layers of red sandstone that formed under intensely hot, oxidizing conditions during the time of Pangaea. Pangaea acted as a gigantic evolutionary laboratory. Every severe drought and extreme heat wave acted as a planetary scale filter, constantly stress-testing life and eliminating biological weakness. Around 252 million years ago, a region known as the Siberian Traps began erupting, and these volcanoes didn't stop. They poured out over 3 million cubic kilometers of lava, blanketing a continent-scale landscape for millennia. This release of magma triggered a lethal chain reaction. Earth's average temperature spiked by up to 10 degrees Celsius. As the seawater boiled and warmed, it lost its ability to hold oxygen, triggering severe depletion across the oceans. Paleontologists call this event the Great Dying. The name is earned. Roughly 90 many ancient reptiles relied on a wide, sprawling stance. Early dinosaurs possessed an upright leg posture tucked directly beneath their bodies, allowing them to move much more efficiently over long distances. They also developed primitive air sacs. These structures allowed them to process oxygen far more effectively than competing predators, keeping them active even when the climate swung to extremes. Because Pangaea was connected, these highly mobile dinosaurs could spread rapidly. A lineage could start in what is now Argentina and, over generations, expand into lands that would become Africa or Europe without ever crossing a single ocean. This global spread acted as a planetary biological insurance system. When a population is confined to one area, a local drought can wipe out the entire lineage. But when an animal spans tens of millions of square kilometers, the risk of total extinction plummets. They would soon need that insurance. Around 201 million years ago, Pangaea began experiencing immense tectonic stress. Massive fractures opened across the crust, triggering a second planetary catastrophe that wiped out 50% of all life. This event, the Triassic Extinction, killed off the giant apex predators and massive herbivores that had dominated the ecosystem. But the dinosaurs, climate-hardened, efficient, and spread across every corner of the supercontinent, endured. With their competitors gone, dinosaurs expanded out of the margins and claimed absolute dominance over terrestrial life. About 175 million years ago, the environment shifted again. Heat from Earth's core was generating slow-moving currents in the molten mantle beneath the crust, advancing just a few centimeters a year. The continental crust could only withstand so much pressure before rupturing. Geologists call this process rifting. The solid land mass was stretched to its limit until it fractured and physically pulled apart. The fractures filled with water. The Atlantic Ocean was born, spreading at the microscopic rate of human fingernail growth. Over millions of years, that tiny separation compounded into vast, uncrossable oceanic barriers. Look at this fossil of Mesosaurus, a small freshwater reptile. We find its exact remains in both eastern South America and southern Africa, two land masses now separated by thousands of kilometers of saltwater that this animal could never have crossed. The geology tells the same story. The rock structures and mineral compositions that form the Appalachian Mountains of eastern North America are highly distinct. Yet, if you travel across the Atlantic to the Scottish Highlands, you find the exact same age, tectonic structures, and mineral makeup. They were once a single, continuous mountain range. The permanent fracturing of Pangaea shattered the unified world. The dinosaur populations were cut off from each other, forcing the survivors to adapt in drastically divergent ways. As the continents drifted apart, the single survival test of Pangaea splintered into dozens of isolated, highly specialized evolutionary laboratories. On the isolated southern landmasses, herbivores evolved into the titanosaurs. Species like Diplodocus developed massive bodies and long biological crane-like necks, becoming some of the largest animals to ever walk the Earth. Meanwhile, the northern continents drove predators in a different direction. Dinosaurs like allosaurs developed heavy, robust skulls engineered to withstand repeated, bone-crushing bites against large prey. To survive those predators, northern herbivores responded with extreme defensive anatomy. The ankylosaurus evolved dense, heavy, bony plates across its back and clubbed tails capable of shattering an attacker's legs. The ceratopsians represent another specialized path. Skulls like this one from a triceratops feature enormous horns and wide neck frills, structures pushed to the extreme for both physical defense and social competition. Had Pangaea remained a single, unbroken landmass with a uniform flow of genetic exchange, this spectacular explosion of diverse dinosaur species would not have happened. The reign of the dinosaurs was entirely authored by the geological life cycle of a planet. From a barren vacuum to a shattered world, their story proves that life is inescapably bound to the shifting rocks beneath it.